Open any mathematics textbook, and the timeline of calculus follows a clear path. It begins in the late 17th century with Isaac Newton and Gottfried Leibniz. This math is the primary tool used to map planetary orbits, to engineer skyscrapers, and define the laws of physics. Yet, the historical record contains a significant chronological gap. The most difficult component of this system, the infinite series, was solved 2.5 centuries before Newton or Leibniz were born. In the year 1350, a brilliant astronomer named Madhava was working from Sangamagrama, a lush coastal village in southwest India. His name is rarely mentioned in Western history, leaving a 250-year period of mathematical development largely unacknowledged in the story of science. 14th century Kerala was an active center of scholarship, where mathematical study was deeply integrated into the local culture. Madhava founded an academic lineage that included scholars like Parameshvara, Nilakantha, and Jyeshthadeva, a group now known as the Kerala School. For generations, these mathematicians recorded and tested astronomical findings, refining their proofs and passing the knowledge to their successors. Their work survives on palm leaf manuscripts like the Yuktibhāṣā. These texts, written in the local Malayalam language, contain the specific proofs for their mathematical theories. These methods were the output of a rigorous, multi-generational institution that operated long before the first scientific academies were established in Europe. Ancient scholars struggled to calculate the area of a circle using straight, finite lines. No matter how many sides a polygon has, it never perfectly matches the continuous curve of the circle. Madhava moved past these finite limits. He realized he could bridge the gap by using an infinite series, an equation that repeats a specific pattern endlessly. Using this concept, he derived the infinite series for sine, cosine, and arctangent, the fundamental functions of trigonometry. These formulas allowed the Kerala school to calculate the value of pi to 11 decimal places, and eventually 17, using only manual calculations. By formalizing the way math handles the transition to infinity, Madhava had identified the core mechanical component that allows calculus to function. 250 years later, in the late 1600s, Newton and Leibniz published their own versions of these exact mathematical series. This timing raises a question for historians. Did European mathematicians arrive at these complex conclusions independently, or was the information imported? During the 15th and 16th centuries, European maritime activity concentrated along the Malabar coast at the port of Muziris, just miles from Madhava's village. Jesuit missionaries stationed here were actively searching for advanced calendar-making techniques requested by Pope Gregory XIII to reform the Julian calendar. These missionaries were mathematically trained and learned local Malayalam and Sanskrit languages, providing a direct way to translate and send Indian scientific knowledge to Europe. While no specific receipt of transfer exists today, the European discovery of the infinite series occurred just as they established an active pipeline to the exact village where that math already existed. Much of this work remained hidden from the West because it was recorded in medieval Malayalam, a language few European scholars could read or interpret. In 1832, an English researcher named Charles Wish published evidence that the Kerala school had priority over these discoveries. His findings were largely dismissed by the Western academic establishment of the time. Modern historians are now updating these records. Foundational formulas are being renamed the Madhava-Newton and Madhava-Leibniz series to acknowledge their 14th century origins. The framework of modern mathematics traces its origins past the research centers of Europe to the visionary scholars of Kerala.